Okay, I have this integral on the board, sine of 2 tan inverse x dx. And what I'm going to do here, I'm going to solve this using two methods. My first method, I'm not going to waste any time as I have to get to the dentist here in a few minutes. So my first method is going to be u substitution. So we have method one, and I'm going to make the u substitution, of course, just the tan inverse, not the two part. So we'll call this our u, and that means our x is going to be tan of u, just inverting this. And then we can take the derivative here, so dx is going to be secant squared u du. Let's go ahead and make that substitution. So we're going to have sine 2u, because that's our u, and then our dx is going to be this thing, so it's going to be secant squared u du. Then next, I'm just going to use the double angle formula here, so we can write this as 2 sine u cos u, and just to save myself some writing, I'm going to write secant squared as 1 over cosine squared. We'll write that in the denominator. Next, we're going to have cancellation, one of these with one of these. We'll bring our 2 out front, and this sine over cosine is just going to be tangent, so we're just integrating 2 tan u du. Then integrating the integral of tan u is just going to be natural log absolute value of secant u. And so the only thing we have left to do is we just need to bring this back to x. And what I'm going to do is, let's use this piece right here, and we'll draw our triangle just to get a sense of what secant of u is going to be. Okay, so looking at our triangle, our angle is u, tan's going to be x. So we need to say opposite over adjacent needs to be x over 1. Then just using the Pythagorean theorem, we can say that the hypotenuse is x squared plus square root of x squared plus 1. Then what we wanted to find was secant value. Cosine is 1 over x squared plus 1, so secant is just going to be this piece, x squared plus 1. Then rewriting this, we're going to have 2 ln absolute value. Our secant u value is just x squared root of x squared plus 1. But I want to take this 2 and put it in the exponent using this property of logarithms. So that's when we square the square root of x squared plus 1, we're just going to get back ln absolute value. We don't actually need absolute value because this is always positive, so we'll just leave it ln x squared plus 1 plus c, and we're done. Okay, method 2, I have my method 1 answer over here. We're going to go ahead, but I'm going to use some of these initial values. We'll repeat some of the same steps. So we've set our u value equal to arctan, inverse tan, and our x equal to tan u. But now, instead of making the substitution, what I'm going to do is I'm going to go directly to my triangle. We're saying if this is going to be u here, then let's just look at what sine of 2u is. Now, of course, we can rewrite sine of 2u as 2 sine u cos u using our double angle formula. But we have our triangle here with the angle of u. Okay, so we were saying we've set this where tan of u is x over 1, so we can actually find our sine and cosine value. So our sine value is going to be opposite over hypotenuse, so this value is going to be x over square root of x squared plus 1. Similarly with cosine, we'll take the adjacent over the hypotenuse. That's going to be 1 over square root of x squared plus 1. We have our 2 in front. Then we'll just multiply this out. We're going to have a 2x on top. And then same thing here. So when we square this, we're just going to have x squared plus 1. So we can actually just take this value and put it back in our integral without making the full substitution. So then here we're just integrating 2x over x squared plus 1. This is actually going to be a really easy integral because the derivative of the denominator is actually the numerator. So this is actually just going to be natural log absolute value x squared plus 1 plus c. But like we found out before, we don't actually need the absolute value here because this part is always positive. And so that's going to be our answer right there. I know there's actually very little difference between the two methods. It's just the very subtle difference of going directly to the triangle and not taking the derivative. So I know it's pretty similar. So stopping it there. Thank you for watching. Please like and subscribe. Have a good day.